All right, so let's do an example, and we're gonna graph this inequality. Okay, so let's draw our graph here, or grid. Right, so here's our x-axis. Okay, and let's just put some all right, so now we'll label these. Okay, so now, the first step is we're going to change this to an equation, right? So I'm going to change this to 3x minus 2y is equal to 6. And so now we want to graph this, so all we need is 2 points. So 2 easy points would be the x and y intercept, right? So let's make x 0. So when x is 0, what do we get? Okay, when x is 0, we get negative 2y is equal to 6. We divide both sides by negative 2, and we get y is equal to negative 3. So one of the points is going to be 0, comma, negative 3. So 0, negative 3 is right here. Okay? And now what we're going to do is make y 0. So when y is 0, we get 3x is equal to 6. Divide both sides by 3, and we get x is equal to 2. And so we get 2 comma 0. So 2 comma 0 is right here. And so now what we're going to do is we're just going to draw the line and connect those dots. Okay? Like so. Okay, now, since this is a strict inequality, we're going to use a dotted line, right? So I'm just going to okay? So it's a dotted line, meaning that the line is not going to be included in our solution set. So all the points on the line will not be included in our solution set. Okay? Okay, so now what? Now we're going to use a test point to see which side of the line we're going to shade in. So obviously the origin is right here on this side of the line, so let's use the origin. That's going to be easy. And what happens when we plug in 0 for x and 0 for y? We get what? We get 0 is less than 6. And that is true. 0 is definitely less than 6. So that means that we're going to shade everything on this side of the line. And we're done. Okay? Now, if we would have plugged that in and got a false statement, that would just mean that we're going to shade everything on the other side of the line. Okay? So now, I don't know if I'm getting ahead of myself, but I'm going to show you another way that you can graph these without using test points. Okay? So what if I take this and just solve for y? So if I solve for y, what do I get? I subtract 3x from both sides. That will give me negative 2y is less than what? 6 minus 3x, right? So all I did was subtract 3x from both sides. And now what I'm going to do is I'm going to divide both sides by -2. Now be careful. When you're dealing with inequalities, whenever you multiply or divide both sides of an equality by a negative value, you must flip the inequality. So if I'm going to divide both sides by -2, then I flip the inequality and I get y is greater than what? 3 plus, oops, this should be -3. -3 plus 3/2 x. Okay? Now the thing is again, if I look at this as an equation, right? And I draw the line, so y equals what? 3/2 x minus 3. So I know the y-intercept is at -3, right? So the y-intercept is going to be at 0, -3, because that's what the y-intercept tells us. It intercepts at -3, right here, boom. And then the slope is 3/2, which means I go up 3 and over 2. And there's my other point. And then so I graph it again because it's greater than I put a dotted line, but here's the cool thing. If y is greater than this, right? If the value of y is greater than this, which is the line, that means I'm above the line. And guess what? I get the shade in the same region. Okay? Now, I'm going to do test points, but also realize that there is an alternative way of doing this. But again, make sure you know how to do test points. Okay? So just to repeat myself, what do? You graph the equation of the line. If it's a strict inequality, the line is dotted. If it's not strict, the line is solid. And then you use a test point on either side of the line. If the test point gives a true statement, you shade that side of the line, that half plane where the point came from. If it's false, you shade in the opposite half plane. That's it. All right. We'll do another example.